My name's Mark Ryan. I'm going to walk you through the Zscaler Private Access API for deploying app connectors programmatically in Amazon Web Services. So I've got a couple of things going on here. I've got a script which is going to build me a new connector. I'm building the connector from scratch as a new AMI. The reason I'm doing this installs a couple of extra tools for me, AWS tools for using the AWS APIs, as well as a couple of scripts that I will run through. So what I'll do is I'll kick that off. It's a build script. It's going to create a connector with today's date using the latest connector binaries and everything. And we're going to create a connector with this date and timestamp on it. So we'll have an AMI created called ZPA Connector 181021, 18th of October 2021, 8:16 GMT. So it's mounting a volume, and it's then going to an EBS volume, and it's going to install Linux into it and all the connector binaries. That'll take 6 minutes or so, and hopefully in that time I'll walk you through everything else that we are going to do. So first off, in the ZPA administration console, the first thing we've done is we've created a provisioning key. Sorry, not a provisioning key, an API key, which I'm calling provisioning API. We've got a client ID here and the client secret I'm not going to display, or in fact we can't display after it's been created, and I'll show you what we've done with that in a second. I've also got map connectors. I've got one already deployed, but I've got a provisioning key created, and the provisioning key has a specific name format, US East 2, which is the AWS region, dash, and then the identity of my VPC, so VPC EC0C 2085, and I'll show you that in a second. So my provisioning key and my app connector groups is going to match the region and the VPC ID for where it's going to be deployed. So I could use this in multiple regions to give me multiple connector groups and create provisioning keys with the appropriate names and use this programmatically. Okay, so let's take a look at AWS. So in AWS, I've got an IAM policy, and the IAM policy has a couple of rules with it. It gives the user the right to read tags, or more specifically, read and write tags on my EC2 instances, and I'll walk you through why we're doing that. It gives the reader or gives the policy, the role, access to read keys from KMS, the cryptographic or key management service, and it gives the ability to read certain parameters with the name ZS something from Systems Manager. So with this role, we associate with that policy, we associate that policy with a role, and that role is called SSM IAM. So we've got an identity and access management role, which has that policy attached to us. So when something is running as that role, it will have access to certain services within AWS, specifically read and write tags, has access to the parameter store, or certain parameters within the parameter store, and it has the ability to read the KMS, the keys. So what we're then going to do is we're going to take a look at the key management service. I've got a managed key in here. So I've got a managed key called Zscaler KMS SSM. And this key is going to be used to encrypt and decrypt my parameters, because I don't want to store anything in AWS that isn't stored cryptographically secure. So I've got a key pair, and you'd come in here and you'd create a new key if you were going to do this. Create a new key. The IAM user has the ability to read that key, and that's about all. It's a multi-region key, so it's copied across all of my regions. Has a specific ARN, but it's a public-private key pair that's used to encrypt and decrypt parameters. And so what we do is, if we come into Systems Manager, and Systems Manager is about the core of all of this, I've created a parameter store. So in the parameter store, I've got a number of different parameters, and as we said, they've got a specific name, ZSAC, App Connector, as I've called it, ZSAC base, client ID, client secret, and company ID. So if we go back to that IAM policy, the IAM role has the ability to access the KMS, and it has access to read these parameters and use the KMS, the keys, to decrypt those parameters. So that's why that's all pulled together. So I have a couple of parameters. The first one is called base, and you can see here it's a secure string. And in this case, I'm using config.zpabeta.net. So I'm on the beta cloud. That's the base URL to build all of the API URLs from. I've got if I go back to the parameter store, I've got one which is my client ID. The client ID will match the API that I copied over from here. That's the client ID. So if I show that there, that's my client ID. I'm not going to show you the client secret. It's obvious what it is. And the company ID, click show here. This is the Zscaler company ID, and that matches this one down here, which is the company that exists, my tenant within Zscaler Private Access. So I've got all the things that I need there to build the URLs for provisioning. So if I come back over here and I have a look at this build script is running, but it's going to put in two scripts into the app connector binary place, and I could pass this as user data as well. It's just that I happen to want to have this as a script that's running on the connector. But it's going to do a couple of things. The first thing it's going to do is stop any ZPA process that's running. It's going to use the URLs, the metadata URLs that are available to you within AWS. So it's going to figure out what region it's in. It's then going to figure out the URL. So first of all, the MAC address. Based on the MAC address, it'll figure out the VPC identity and the actual VPC that it's running in. And remember that the key, as in the provisioning key URL name, is region dash VPC ID. So all of this is about enumerating, what VPC and region that the connector is going to be running in, so that I can build the provisioning key name and then be able to request it from ZPA programmatically. And we're also going to pull out the instance ID, the unique identity for the EC2 instance. So what is the EC2 instance name? So then I've got 4 URLs. Each one of these is going to pull out the client secret, the company, the client ID, the company, and the Zscaler base URL from our parameter store. So it's AWS SSM get parameter, then the name of the parameter that we called it programmatically in the parameter store. We're going to query for the value, and we're going to use the decryption to decrypt that key. And when it says with decryption, it's then going to go off to KMS, get the KMS key to decrypt it, and then decrypt it and pull out the actual value. So of course, to be able to run this AWS command, it's going to run as a role, and that role has to be able to read this parameter, and it has to be able to read KMS, the values, to be able to decrypt it. So that's why we created that IAM role. Okay, so we've got all of those parameters. We're now going to create our post request. So the post request is going to say what's the client ID, the client secret. We're going to then go off and get our bearer token. So this is effectively logging into the API and getting the bearer token for every subsequent request that we're going to make, our OAuth requests. And then we're going to say, right, let's get, we know what the base URL is, config.zpabeta.net or config.private.zscaler.com for production. We use the management config URL. We know what our company ID is because we pulled that from the store. And then we're going to say, give us a list of provisioning keys that match this name. So the search is the key, and we know there's only going to be one. It goes off and gets that. And then what it does is it takes out, uses JQ, which is for taking JSON data, and it's going to pull out the provisioning key itself, not the rest of the JSON data, and it's going to output that to the provisioning key file. After that point, it just starts the ZPA connector. The connector will go off, it'll join the cloud, and then we'll be part of Zscaler Private Access for this company. Now, once it's provisioned, obviously it gets all its certificates and everything, and the actual certificate, the public certificate, not the private certificate, which is encrypted, but the public certificate has a subject name on it, and that subject is actually the connector ID, the identity, unique identity for that connector across the entire cloud. And so what we will then do is we'll create a tag on the connector so that we can identify that uniquely within our list of connectors. So we create an EC2 tag for it, which matches the connector ID. So we've got all of that data available to us, and we should then have joined the cloud. Similarly, we've got a deprovision script if we want to go off and deprovision and reprovision, or you could run this as a lifecycle hook when the connector spins down. If we were to build this into an auto scale group or a launch instance config, we can do this as well. So again, it's going to read the instance ID from the metadata. First off, we stop the connector, read the instance ID. We're going to read the connector ID from the tag. Of course, we could just look at the certificate, but we'll keep this consistent. We figure out the region, and then we go through reading all of those parameters again, logging in, getting our bearer token, and at this point we just call the URL. The URL is the company, and then we've got the connector ID, and all we're doing is running an HTTP delete method to that URL with that bearer token, and we will delete that connector from the administration interface. At that point, because we've deleted it, we'll delete everything from the var directory, which is all of the provisioning keys that are encrypted and everything, and we're back to the initial state. Okay, so let's see how much I've been talking, and yes, the couple of minutes that it takes, at least the 300 seconds for the snapshot to complete, and we've now got our new AMI. So let's come across to AWS EC2. Okay, and so if we look in AMIs, these are my company AMIs, are the ones I created. I've got a couple from last week, and this one here, 18th, 10/21 at 8:16. So we're ready to go with that one. So I can click launch. I'm going to use the T2 micro. This instance isn't restricted on which instance types it's allowed to use. Obviously you wouldn't use T-type in production. we're going to configure some instance details. So I'm going to associate this IAM role that I created earlier, which means that anything that runs on that instance is going to run within that IAM context, having the access to the parameter store, having access to read and write those tags, having read access to the KMS for the key store. So I'm now going to make sure that it runs that provision script at launch as part of the user data. I don't need to add any storage to it. I'm not going to add any tags, but I could have added a tag for the name and things like that. I'll review and launch, and I'll click launch here. I'll pass it my key pair, and I'll click launch instance, and it should then launch that instance. So let's come across and have a look at this instance. It will take a minute to launch. Here is the instance. Got our public IPv4. I'll copy that to the clipboard to save me typing that in. Let's refresh this. So it's initializing. And whilst that's doing that, what I'll do is I'll flick over to my command line, exit out of my my build AMI, and what I'll do now is SSH -I and it's admin at, and then the instance name. Okay, so we're up and running. So if we ls opt Zscaler var, we should see all of the enrollment data is there, as we'd expect after provisioning. And if we come into Zscaler Private Access and come to our app connectors, provided we haven't logged out, there we go. We've had a new app connector created with that provisioning key. It is connected to the cloud, and it last disconnected, well, about a minute ago. So we've now got a connector that's up and running with the latest AMI version, the latest version of our Sarge, which is our controller software, all up and running programmatically. Now, to simulate things, I can also go /opt Zscaler bin deprovision and run the deprovision script. Again, that will use KMS, read the parameters again, connect to the API and delete everything. If we look in that Zscaler var directory, everything's been deleted. We can click refresh. Connector has been removed. And we can run the provision script again if we want to reprovision it. Click provision. Again, get the API, get the provisioning key using the API, and provision ourselves back into Zscaler. Data's back being created. We'll refresh this, and the connector's been recreated. So we can do all of this programmatically. We can pass that as user data to have it run at launch. We can build that as part of our launch scripts or our CloudFormation templates or whatever, to have these built programmatically as part of auto scale groups, and then scale back using those lifecycle hooks as well. So hope that was useful. Any questions, please email me, mark@zscaler.com. Thank you.